I'm CK. Tonight we've got a looping envelope generator from AI Synthesis up in Portland in the United States. I haven't built anything from them before, so I don't know their design sensibilities and how their kit goes together. So it'll be fun to play with that, and we'll see what we get in the end. It sounds like it might be an interesting little unit. Hope you enjoy the video. Here's the package from AI Synthesis in Portland. Contact form, looping envelope generator, full kit, AI003, so I'm going to assume it was their third product. Let's see what's inside this padded bag. Another bag, and nothing else. By the way, I bought this directly from them. I didn't go through a third-party retailer on this or a reseller on this one. So we've got eurorack power cord, power header, then a whole bunch, I'm not real happy about this, a whole bunch of little plastic bags. Arg. I hate whole bunches of little plastic bags. They're just so wasteful. But, got 2 stickers and a guide to where the build guide is. Let's look over here. We've got the main front panel with some raised gold trim, looping ADSR, envelope out, loop and envelope, we'll see what that means. ADSR, self-explanatory. Manual, I don't know what that means. Maybe that's a button to trigger it manually. Retrigger, again, I don't know whether that's a button or whether that's an input. And there's the gate to actually fire it out. And there's the envelope out there. And envelope out there. I wonder why there are 2 envelopes out. Maybe one is for loop. I don't know. We'll find out. Let's look at the circuit board. 2 circuit boards. It's a little... It was from a multi-panel board, so the edge is a little raggedy where they split it. I always take a little bit of fine sandpaper and take that roughness off. You don't have to do that. It just makes, I like smooth edges on my PCBs. Be nice if they do that at the shop before they shipped it out, but yeah, there's another one that's rough edge too. Okay, let's look at the boards themselves. First off, and always good, all the values for the components are silkscreened onto the board. The board itself looks good quality. The holes are all plated through, which is good, means much less chance of cold solder joints. Here's the power header, and you can see there's a little caret here to indicate, I'm assuming, where the -12 red stripe goes. The traces are very visible. If you want to learn some electronics, this is a good board to do it because the traces are all really clear where things are going to. That's kind of nice. Here's the front. Okay, so retrigger is a socket. So I'm looking here. retrigger, gate, and there's those. So envelope and loop, that's a 3-position switch, or a 2-position switch. Oh, envelope out, that's actually an LED, so it's an indicator. Okay, that solves that little mystery. Oh, I'm going to be throwing out so many little bags. Arg! ICs, knobs for later. Kind of knobs. Oh, they're just push-ons with little Allen screws. So that's metal into plastic, which you always have to be very careful with so you don't strip it out. 1 transistor. Some electrolytic caps. The LED that's going to go through that gate indicator. Pin headers. Some standoffs. Spacers, whatever you want to call them. The double pole, double throw switch. Capacitors. Bunch of diodes. And that's a lot of diodes. Huh. Now, individually packed resistors. Again, guys, go look at what Division 6 does when they pack their parts. They're the least wasteful of anybody, and because this is all a bunch of little bags. I mean, come on, I'll try and send them back to them. Maybe they can use them again. A couple of pots, retrigger switch or trigger switch, push button that is. More resistors, another pot. Jacks with the panel nuts already taken off, which is nice. And another pot. And that's it. Pretty straightforward, nothing too unusual in that collection of things. One unusual thing that I did not actually look at, where is it? Where's the other pink bag? Okay. I was just looking to see whether the ICs were socketed, which is typical, but some people on other kits, not in any eurorack module I've built, some people go directly to the board, but this is good. So this is a TL72 op amp and then a TL074. I know what that is. I think that's a, well, I'll look it up because I'm not going to guess. But I think it's a counter, but I'm not certain. I'm not saying that's what it is. Okay, so we'll get the soldering iron heated up and dive into this. And as we start, here's the build guide on their website. Seems fine. Here's the bill of materials. Oh. They've got some video. I wonder how long this video is. Huh, this build guide may already have, it's 40 minutes.
Welcome to the build guide for the AI-003.
Huh. Maybe they don't need me to do what they're doing. But I'm going to do it anyway. And their build guide came in at 40 minutes. I'll probably come in maybe even a little longer than that. Ha! So set that up on my stand. And we're going to do all the resistors. So, as people who've watched my previous build videos know, resistor time, there's not a lot for me to comment on. Putting all these resistors on the board. So, I will set the cameras, or the video, to speed it up playback, and you can watch me put resistors on the boards very quickly. So enjoy resistor time. That's another episode of Resistor Time over, and as I went through it, I got more familiar, of course, with the design sensibilities and how the board's going to go together. And I'm going to start calling AI Synthesis the anti-Bufaco, because their layout is almost diametrically opposite to the way Bufaco does it. Their traces, as I've already mentioned a little bit about, are all straight lines. There's tons of space between the components. You're never going to have to worry about bridging contacts or feeling cramped. All the silk screening is very clear. It's not clipped off because things are jammed too tightly together. As I look at this, this is a great starter style board. You know, they could have, whoever designed the board, could have crunched things together a good bit and taken off 1 or maybe even 2 HP from this, but they chose not to, and it's very easy to build because of that. That's kind of nice. Let's see, let me go through the build guide to where I am. Lots of pictures in the build guide, of course, which is very nice. And then he, where are we? I'm trying to see how he's going next. He put diodes in interspersed with the with the resistors. Well, I'll go ahead and put the diodes on now, which is almost as much as interesting as resistor time. Particularly this time, because there are 10 4148 diodes, which is a lot. This designer is very interested in circuit protection. So again, we'll go fast through the diode placement. Next, we'll put the IC sockets on. Only 2 of them. Notch down this end. Hold it on the back with my pinky finger. Solder one leg. Let it cool a little bit. Now look to see if we're all aligned. Yeah, actually that went just fine. So I don't have to do anything with that one. Now let's get the other one. Socket's done. Now we'll do the pin headers. And it looks like that's interesting. He goes back to back on these. So different than some other modules that will often stack like so. Looks like he's going to be stacking like that with the components facing outwards. Neither good nor bad, just interesting. And with that in mind, of course, we could do male and female on either board, or even alternate them, but I'll stick with what he's got planned here. So I'm going to put both pin headers on and put them on my little solder block so it sits level. And yes, I'm using the very last piece of solder. If you went through as much solder as I did, you'd use every millimeter of solder you had too. You could too. Let's see how that worked out. Not quite perpendicular, so put my thumb on the back, reheat that solder joint. There we go. Now it's right straight up and down. Do a little touch up. Yep. There we go. That one's done right too. Good. Power connector. And as I always like to do, he says that the power connector notch should go down. And he also recommends what I also always recommend, just put the power cable in too, just to verify that the negative stripe is facing the right way. Double or triple checking that will save you nightmares. Next, we're going to put the transistor on board. And goes over here. Just double checking the part number. Yep. And again, even with these transistor pads, there's such a lot of space between them. It's going to be hard to make a mistake. Now the last few electronics parts, not mechanical parts, for the board. Two big old smoothing caps, and the board is marked very clearly where the positive lead goes. Now these are straight up and down, where, hold on a second, let me clip these leads off, where this one is the third 10 microfarad, and as you can see, it's on the control side, which means the panel's going to be on top of it, which means this one's going to have to lie down a little bit. And interesting, this one's marked, the negative lead on this one is marked, not the positive lead, which is always interesting. So we'll put the cap in a little bit of the way, see how much lead we need to lay it flat. Okay, that's how much lead we need to lay it flat. I wonder why, I wonder if he, I mean, it would be odd to use different software. It was all on one circuit board, master, so I don't know why this one has a different indicator for the positive lead, or in fact for only the negative lead, where the other ones identified the positive lead. Just unusual little bits of detail that you never know when you're going to come. So now it's time to build up all the componentry for the control board. So let's see, these are all, again, the board's all marked with the appropriate values of the potentiometers, but we'll go kind of this way. We'll put the jacks on, and of course, as per most eurorack modules, we won't solder anything just yet because we want to make sure we get them all aligned. This is the 500K audio taper. I think that this is audio taper. Ah, there goes my... There goes my water heater. I'm gonna turn the volume down while my water heater goes through its cycle. Nothing much to talk about here anyway, just mounting components. Okay, so the water heater has gone off so you can hear me again. And nothing too out of the ordinary on the mounting the components. The only thing that is a little, there's a gap between the flush mount here on this push button and the circuit board, so just make sure you push it all the way down before you solder it. The LED AI synthesis uses the little plastic spacers to raise the LED the right distance off the circuit board, which I find very useful. Division 6 also does this. I would love it if everybody did that. They're very handy to make alignment just perfect. And you also may note that I don't put the washers behind any of these because I don't like them. And this is going into my studio rack, which never moves, never goes anywhere. So I don't need anything, any of the features that a washer would help you with. The other thing I did was put the spacers on, and of course you got to remember to do that before you put the panel on for the final time, or else you're going to be sitting there saying, oh, I got to put these spacers on, and you can't do it because you can't get at them. Okay, I've got two leads left on these LEDs. Do we think we can do these two leads with this little bitty piece of solder? I think we can. Let me spread these out, that'll help me. Perfect, and I've still got at least one good solder joint left on that piece of on that tiny piece of solder. Now with everything, when I think the board is done, I take an index card, or in this case AI Synthesis's business card that they include, and I just go down the back of the circuit board, isolating a line at a time so I can make sure everything is soldered and all the solder joints look good. I have often, not every build, but enough to make this very worthwhile, seen a missed solder connection or a solder connection that might potentially be cold. Now see right here, I didn't solder the other end of this diode. Huh, what do you know about that? That's why I make the final pass with my little index card, and I will get to use this final little piece of solder. Always double check. I've built more pieces of electronics than you may not believe, and I still make mistakes like that. So just double check, triple check, quadruple check. Doesn't hurt anything. I'm going to put the ICs on the board now. Make sure the notch is right. All pins in, all pins straight. Oops. So it's coming out a little crooked. Did I bend the pin? Nope. All pins in, no pins bent. So now it's time to mate the two boards. Make sure we're doing it right. That's not right. That is right. We'll slide them together. And now we'll put the other two screws into these spacers. Now just be aware that these spacers are plastic and you're putting stainless steel screws into them, which means if you're not careful, you could strip the plastic out, so don't make them super tight. Just tight enough to provide a little stability. Okay, so that's the build. There's one side, the back, other side, top with a little spacer for the LED, and bottom. Now it's time to put her in the rack and watch the curves. And we're in the rack, and for today we're going to be having the Befako Midi Thing sending trigger and CV voltage for note value. We have the even VCO from Befako as our oscillator today in the test rack. We've got a frequency central more VCA that we're going to be playing with, that's taking the envelope. And here's the envelope itself. And I've got a spider on the, or octopus on the bottom, going to both the VCA and over to the oscilloscope. So let me zoom in and let's give her a try. So the author, and I think he's the designer too, says the best way to test it is simply go into loop and you should see the light flashing, and I think it's going too fast for me to see the... Oh, okay, there we go. So you can see the LED flashing, and on the scope you can see the envelope with everything turned down. So let's go out of that mode, and now we'll actually go, let's say, a quarter up on attack, quarter up on decay, and a quarter up on release, and see what the waveform looks like and see what it sounds like. Nice and clean. You can see the curve is pretty equal on both sides. Let me put a little bit of sustain in there. Let it tail off. Let me increase the release segment a little bit. And it tails off over a much longer period of time. Increase the attack. Let's make that really kind of funky sounding. It's got a sharp drop off even though I'm holding the key down, of course. What else do we have in here? Let's go into loop with something interesting on it. Interesting, I'm getting It's as if I'm getting a little voltage when I go into loop. Huh. So you can get a very rhythmic, sound. Now I don't know if you can, I didn't see whether you could adjust that, because as you'll notice, it's not hitting the release at all. Doesn't have time. So I'm not sure I would ever use the auto. If I were going to do this, I'd probably trigger it from an LFO, but that's just me. I'm going to put it on the sequencer right now, the Division 6 sequencer, and we'll have it do CV, note CV and gate, and see what we can get out of that. Let me speed it up. It's as fast as it goes, and as you can see, it gets very muddled. Let me pull things out here. So I wouldn't say it's as responsive as some ADSRs I've got at higher speeds, but it does the job. Let me switch back to my MIDI keyboard. So it works fine. I really do. I'm going to pause the cameras briefly to see if I'm missing something about the timing on the loop. I guess by having the attack and release can somewhat control the timing of the loop, but that's kind of imprecise. Yeah, that doesn't really give me what I want, but that's okay. It's a good little unit. Easy build, as you saw. This is probably a really good build for a beginner as your second or maybe third module. As I said, there's lots of space on the board for the components. You're not going to bridge anything. It goes together very quickly. Works fine. So that's the looping ADSR from AI synthesis. Hope you enjoyed the video.